So today for solving two-step equations, we're going to start with a word problem. And it says that the height of a tree after x years is 1.5x plus 15. When will the tree be 24 feet tall? So it's telling us that the height of the tree is 1.5x plus 15. So if that's the height of the tree and we want the height of the tree to be 24 feet tall, then we're going to say the height of the tree, we want it to equal 24. Again, this is the height of the tree. That's what the problem says. The height of the tree after x years is this expression. So we're going to take this as the height of the tree equaling 24, which is what we want. And now in order to find x, which is the number of years that it will take for the tree to be 24 feet tall, since x is on the left side of the equation, we're trying to get x all by itself. Now you notice that x is next to two numbers this time on the left side. We do not want to move the x, we want to leave it where it is. All we're going to do is we're going to reverse the operations of the numbers we have here using inverse operations. Now, there's two numbers to eliminate. The 15 has to go and the 1.5 has to go. Once they're both gone, we have x all alone. Now the question is, which one do we get rid of first? Now, in the process of solving these, you always want to start with addition or subtraction. Now, if you recall, order of operations helps us to solve a problem, but if we want to undo the problem and get back to the original number, we're going to, instead of going down, that's to evaluate an answer. To solve it, we have to go up. So our first steps when we're solving are always going to be addition and subtraction first. Then we're going to undo multiplication and division second. Okay, so this is for solving. So when you're solving any equation, you're going to do order of operations backwards. Some people are used to seeing PEMDAS. I write GEMDAS because G stands for grouping symbols, E is exponents, this is multiplication, division, addition, subtraction. Again, when we're trying to reverse the order of an expression or an equation, you're going to go backwards. So starting with addition and subtraction, then multiplication and division. So with that being said, where do we have addition or subtraction? Here. So then we're going to reverse that addition by subtracting. Some students just already know that addition and subtraction is the first step. That's going to be nothing. And on the right side, we're left with 9, positive 9. So now I have 1.5x equals 9. So 1.5x equals 9. I need to eliminate the 1.5. So to eliminate the 1.5, you ask yourself, what operation is happening here? And it's multiplication. Multiplication is going to be the only invisible operation. It's next to a variable, means it's being multiplied. If there's a number next to a variable, it's an invisible multiplication. So to reverse the multiplication, the inverse operation is divide. I'm going to squeeze it in here. So when I divide both sides by 1.5, on this left side, 1.5 divided by 1.5 gives me an imaginary 1. It's invisible there. Not imaginary, sorry, invisible 1. And 9 divided by 1.5 is 6. Now, if you're not sure how I got that answer, I've done this before where you draw a hill, and I've told students before that king of the hill goes in the hut. So 9 would be the king on top of the hill. He goes in the castle. Castle, not hut. So 15 goes into 9. You're not allowed to have a decimal out there. So you move it over. If you do it on the outside, you do it to the inside. So you really convert it to 15 goes into 90. Now I know that 15 and 15 is 30, and there are another set of 30s in there. So that's 6. 6 times 5, 30. 6 times 1 is 6, plus 3 is 9. And there, how you get 6. Alright, so that means in 6 6 years, in 6 years, the tree will be 24 feet tall. All right, so next one. Example 2. Now, back to this one really quick. It's called the two-step equation because the first step was reversing the subtraction. Second step was reversing the multiplication. So the inverse operations is 2 of them. Next one we'll say is 2x minus 25 equals negative 35. So this is also a two-step equation because I can see that there's two numbers that are going to need to be eliminated so that x can be isolated by itself. And again, your first step is always to start with addition or subtraction. I see a subtraction here, so I'm going to add. That's going to be 0. It's going to be negative 10. So you have 35 negatives, 25 positives. You have more negatives left over. 25 zero pairs. So those negatives are left over. And we're left with 2x over here. Rewrite it again. Negative 10. So now I'm one step closer. Now I got to get rid of that 2. The 2 is being multiplied with x. So the inverse operation is to divide by 2. Now, I don't divide by 2x because that would cancel everything. I only want to get rid of the 2. So I only need to divide by 2. I'm going to keep the x there. So don't try to eliminate that by putting an x here. So 2 divided by 2 is invisible 1. And 10 divided by 2 is 5. A negative divided by a positive is a negative. So this would be negative 5. And you don't need the 1 there because it is invisible. We just say x equals negative 5. Again, the first step was the addition. The second step was the division. Next one. Example 3. And it's x over 2 minus 9 equals negative 25. Now, I'm going to do something a little different on this one. I've got to do it on the other ones, but I like to write down what my two steps are going to be. That way I kind of get an idea of what I'm going to do before I actually do it. The same thing is going to happen. X needs to be all alone, so I'm leaving it alone on the left side. And there are two numbers that need to be eliminated. In this case, can you think about which ones they are? It's negative 9 and 2. Once those two numbers are gone, x will be all alone. So, which one do I get rid of first? The one with addition and subtraction. So I'm going to add 9 first. That's going to be my first step. And then after the 9's gone, the next step is going to be to reverse this operation. I see this is division of 2. So when it comes time to get rid of the 2, I know I'm going to have to do the opposite, which is multiply by 2. So those are the two steps I'm going to do. For the 9, I'm going to have to add 9. To get rid of the 2, I'm going to have to multiply by 2. Notice they're the reverse operations of what I see in the problem. So now I'm going to go ahead and do that. Step 1, add 9. It's always nice to map out, plan ahead what you're going to be doing. That's 0. And on the right side, we have Alright, so you have 16 negatives because there are more negatives to start with. There was 9 zero pairs that canceled, but you still had 16 negatives left over. And so now we have x over 2 still there. Now it comes time to get rid of the 2. To get rid of the 2, I notice it's division again, and I already know that step is going to involve multiplying by 2. So now, you can put a 1 in here if you like. Cancel that out, or think of this as 2 divided by 2, which is invisible 1. And negative 16 times 2 is negative 32. So again, that's a two-step equation. Another two-step equation of a different style would look like let's map out our steps. X needs to be all alone, and the numbers I need to eliminate in this problem are 6 and negative 10. Which one is going to be eliminated first? The addition or subtraction first, and that would be this guy. I see it's addition, so that means my first step is to get rid of the 6 by subtracting. The next number I need to eliminate is a negative 10. I notice it's multiplication of 10, negative. So the opposite of multiplying by negative 10, or the inverse, is to divide by negative 10. So those are the steps I'm going to do. So let's go ahead and start. I'm going to subtract 6, and that gives me negative 14. Negative and negative makes more negatives. There are no 0 pairs, and just a lot of negatives left over. All of them are there, 14. And this is a 0, and now we're left with negative 10x. So now we have to get rid of this negative 10. I already know ahead of time that I'm going to be dividing by negative 10. That reverses the multiplication. Negative 10 divided by negative 10 is an invisible 1. And 14 divided by 10, or 14 tenths, you can think of it as 1.4. Negative divided by negative is a positive. When you divide by 10, the number gets smaller by 1 place value. So I just move the decimal to the left. 1.4. And the last example I want to show you, looks a little daunting, but it's doable. All of this divided by 5. Now, I did say before that addition and subtraction needs to be your first step. There's two ways to do this. You can notice that 5 is dividing the whole expression. So if we want to subtract a 3.5, what are you going to do when it's got a division of 5 there? So you can either split it up, or you can just eliminate it altogether. So in this particular case, we're going to simplify first. So you want to get rid of this 5, so that way you can focus on what's there. Now, this is a division. So in this case, we want to get rid of that first. So I'm going to multiply by 5, because the opposite of dividing by 5 is multiplying by 5. Second step I'm going to do is get rid of this 3.5 once this is gone. It's a positive 3.5, so to get rid of it, I know I'm going to subtract 3.5. I put a negative 3.5. So let's see what that looks like. This is the goal. I cannot subtract or add first, because this is divided by 5. So I want to get rid of that first. It's kind of a simplifying step. We're not really solving yet. So I want to get rid of the 5. Multiplied by 5 on both sides. Okay, so once you do that, 5, the one here, you can cross cancel the 5s, or think of this as 5 divided by 5 is 1, and it all cancels out. And then on the right side, you have 15 times 5. So 5 times 5 is 25. Carry the 2, that would be 7.5. So now I have to get rid of this 3.5. That was multiplied. This becomes 0, or just 4. So x equals 4. Now this is a special case. When you have division of an entire expression and not just one number, you want to eliminate that first. Even though it's not part of the solving step, this is considered a simplifying step. So we're simplifying by getting rid of this 5. And that's it for solving two-step equations.